Hey there kiddos, here's your video on rational exponents, which are going to be exponents that are written like a fraction, which do exist, and we're going to treat them in special ways. So we're going to talk about something called flower power first. So if you have a base like x taken to a rational or fractional exponent a over b, you can rewrite it as the root, the b, of the base to the power of a. So if you think about a flower, okay, if you have a flower that looks like this, down here it has all the roots growing underneath the ground. So if this is like our fraction, my root is on the bottom. So this is my root. And my power, my flower power, sits on top. So when I rewrite it, I write it as the root, whatever the root may be. Usually it's a square root, but it could be a cube root or a fourth root, to whatever the base is to that power. So we're going to do some examples and I'll show you. But for example, if I had x to the 2 over 3 power. What that means, if I have x to the 2/3 power, I'm going to rewrite it as the root, which is the bottom number, so it's the cube root, that's what the 3 means, of the base to the flower power inside. So the roots stay outside, the flower goes inside, and so that's what that looks like. And so if you think about it, if I have x to the 1/2 power, I can rewrite it as the second root, which we usually leave blank because the second root we also call a square root, and that's what that symbol is, of x to the 1st power, which is just the same thing as the square root of x. And so the x to the 1/2 power is the same thing as the square root of x. So that's what that means. But if you can remember the flower power, it lets you know the flower goes in the house, the roots stay outside because we don't like roots in our house. So if you go, and we're going to write this down, you can put it, tack it onto the very top of your notes, or you can squeeze it in on the back of your agenda or something, but find a place for it. So if you have a to the m over n, it can be rewritten this way. The flower power, like I just taught you, with the roots. Oh, those roots are so much better than my roots. But the roots are on the bottom, the flower power is on top, so the roots go out, the flower stays in. So let's do a couple of more examples just so we can get it down. So this x to the 5/8 power is the same thing as the 8th root, because it's on the bottom, x to the 5th. Now if we're going to take it apart, the base is what's inside. This is the flower, so it goes on top. This is the root, so it goes on the bottom, so it becomes x to the 2/3 power. So it's just backwards. So you go back and forth. Just try to remember flower power. Okay? So let's practice a few. So the first few we're going to rewrite. 1 and 2 we're just going to rewrite as a base with an exponent. So we happen to know that the square root of 9 is just 3. So the square root of 9 is going to be 9 to the 1/2 power, because we talked about how there's an exponent of 1 here and there's an understood 2 outside of the square root, so it's 9 to the 1/2 power. I'll know that you understand that the square root of 9 is 3, but it asked you to rewrite it as with an exponent, so that's how we're going to rewrite it. So the square root of 16 would be 16 to the 1/2 power, because you have the exponent of 1 with the understood root of 2 when we just write the radical. So 3, 4, and 5 ask us to rewrite it as a radical expression. So now it's going to have to contain the root. So if we're going to rewrite this one, you have your cube root of 5 squared. So you have your 5 to the 2nd power. And we're going to stop right there so that if we needed to take it apart that we could. This one is the 7th root of 9 to the 1st, or just the 7th root of 9. And then this one is the cube root of 2 to the 5th power. So you're just going to take it apart or put it back together, either way, but they mean the same thing. This written with the radical is the same thing as this with the fractional exponent. And just a fractional exponent means you're going to have a root of some sort and not taking it to a power. So you're not actually multiplying it times itself. You're creating a root. So let's simplify some expressions. So we're going to remember our rules that we've been talking about for all this whole time. And so if I've got an exponent outside parentheses like that, means I'm going to have to distribute that exponent to everything inside. So I'm going to be multiplying. So this is going to become 27 to the 1/3 power. Then it's going to become x to the 3 thirds power, because when you multiply a whole number times a fraction, you just do 3 times 1 over that denominator. So same with the 6, I do 6 times 1 over 3, so it becomes 6 thirds. And then I'm going to reduce my fractions if I can. So the 27 to the 1/3 power stays, because 1/3 can't be reduced. But 3 over 3 is the same thing as 1. And 6 over 3 is the same thing as 2. So it does simplify down to that. So it's simplified. That's as simple as it gets. So let's try. I believe this is your number 7. I don't know what's up with my numbers. This should be number 8, and that's definitely number 9. So I'm going to distribute again to every part that's here. So I'm going to have 16 to the 1/4 power. And then I'm going to have x to the 8/4 power, so it's 8 over 4, over x to the 6/4 power. And let's go ahead and reduce that. So I have 16 to the 1/4, and you can type that in your calculator. You can do 16 to the 1/4 power so that it will tell you what it is, but it's going to be 2, because that's the same thing as the 4th root of 16. So what number times itself? It makes a 2. So because 2 times itself 4 times makes 16, so 16 to the 1/4 is going backwards, so it becomes the 2. This becomes x to the 8 divided by 4, or 8 over 4 is x squared. And this right here, 6 over 4 becomes 3 over 2. So I'm going to have to subtract these two exponents because I have like bases and I've run out of space. I'm going to make myself some room here. And so I'm going to subtract my exponent. So I'm going to keep my 2, and I'm going to grab my calculator, and I'm going to just type in 2 minus 3 over 2 into my calculator and just have it go ahead and take care of that for me. And when I do that, I get that it's 1/2. So 2 wholes minus 3 halves makes 1/2. And so I end up with x to the 1/2 power. And so that's going to be my final answer. I'm going to leave it just like that. So that's what happens when I do that one. If we go back up here to number 6, let's go ahead and simplify. 27 to the 1/3 power is like asking for the cube root of 27, which happens to be 3, because 3 times 3 times 3 makes 27. So if I'm going backwards, 27 to the 1/3 makes 3, because that's the number that multiplied to make that. X to the first y squared. These are the same thing. If you leave it here, it'll be okay. Just keep in mind, if you happen to have a multiple choice question, you're going to want to be able to simplify it as far as possible. So number 8, we're going to have to get rid of parentheses first by distributing. So this first one, I've got to distribute the 2 to everything. So this becomes x to the 4th y squared. And this one right here, when I distribute my 4 times 1/4, I get y to the 4 over 4, which is just y to the first. And so then when I multiply these together, I will add my exponent. So I keep my x to the 4th because there's nothing to multiply it with. But for my y's, I will add the 2 and the 1, and I'll get y to the 3rd. So this last one here, number 9, I'm going to write it out the long way. I'm going to distribute this 1/2 to every part here. So I'm going to do 49 to the 1/2 power, which if you'll remember, that means the square root. I'm going to do x to the 4 over 2, which is 2 power, y to the 6 over 2, which is 3, and z to the 10 over 2, which is 5. And if I do 49 to the 1/2 power, that's the same thing as asking for the square root of 49, which is 7, x squared, y cubed, z to the 5th. So that's your final answer. Oops. And so that is what rational exponents look like. It's still the same rules as before. The thing that you need to remember is that to the 1/2 power means the square root, 1/3 means cube root, 1/4 means 4th root, whatever. And if it happens to be a different fraction, 2/3, 5/8, 6/7, whatever, you just take it apart and remember the flower power so that you can put it inside. So you have the flower power, so the roots stay out, the flower goes inside as the power. So that's rational exponents. We'll practice this tomorrow. I'll see you then.